Hey guys, just doing another quick video. This one is on PhyPhox, but actually showing you what data to collect and being more specific about it. So it's a little more involved than what I've shown previously, but I've done some research into it, and this is how you're going to do it, okay? Because we need to do it properly. We need to do it with proper physics, all right? So the first thing to keep in mind is this is your phone, okay? You're using this as the accelerometer. Oh, it's gone weird. I'll bring it to the home screen. So the front of the phone is the screen, okay? And in 3 dimensions, there's 3 axes. There's the x-axis going left and right. So if the phone goes to the right facing you, that's going in the positive direction on the x-axis. If it goes left facing you, that's in the negative direction on the x-axis. The y-axis is up and down. So if it goes up on the y-axis, that's positive. On the y-axis, if it goes down, that's negative. And then lastly, if it's facing you and it moves towards you, that's positive in the z-axis. And if it moves away from you, that's negative in the z-axis. Okay? Now why is that important? Because that determines what readings that you're going to get on PhyPhox. It has a weird angle, so I'll open it straight into this. So when you do the setting that we use, acceleration without g, you're going to notice that it's getting readings for the x, the y, and the z axis. You need to decide what axis you're going to get acceleration from based on the direction of the impact. So that completely depends on how you attach this accelerometer on your phone to the trolley that you're crashing, okay? So if I was to put the phone side on, facing this way when it crashes, that's going to be having an impact on the x-axis. You probably don't want to have the phone side on like that. If I put the phone like this with the top of it, ignore that screen, the top of it facing the front, so it's lined up, I'll show it like this, then that's going to be crashing along the y-axis. That's probably my recommendation to you if you're not sitting it up in like a seat or something. Then the other option is this, because some of you may be choosing to design like a car seat and a seat belt, so your phone would be sitting in the car like this. Well, the direction of impact is going to be like that, so it's going to be along the z-axis. So I would recommend to you guys mostly be using the z-axis, but possibly the y-axis if you're not using a seat. Okay, it just has to be the same with your methods. Okay. Now the next thing I want to do is show you how to do a reading. So for simplicity's sake, I'm going to attach the phone like this. So the top of the phone facing the front of the car. So the axis of collision is going to be along the y-axis. I'm going to open PhyPhox. Just show you the settings again. We go acceleration without g. I'm not going to do any timed runs here. I just want to show you the actual graph and how to read the graph, what you can actually get data from. So we already know that the axis I'm going to look at is the linear acceleration on the y-axis because the phone is facing that way. Okay? Acceleration without g, y-axis. No, it won't. You can see on my phone it's got the y-axis selected. It's not showing that on the screen. So, oh, there it is. Okay, it's just a bit laggy. So we're looking at the y-axis. I'm about to start a trial, so I press the play button, run it. That's a trial, okay? So what are we reading off? What data are we actually going to collect? You're going to save all of these screenshots. You're going to save all of these graphs so you have evidence of the raw data. But what you're actually going to put in your table is the peak deceleration, okay? So if we observe, if we zoom into this, what's happening? So as the cart rolls down, it's accelerating in the positive y-axis because it's moving in the direction of the top of the phone. What's all of this? Well, it's vibrating because this is not traveling perfectly smoothly. And as we go, so you're ignoring all of that vibration there, what are you actually going to get the reading for that you're going to average out to tell me whether the crash was weaker or stronger? You're looking at this, okay? So when it hits that point there at the start of this downward dip, that's when it hit this box, and then it got decelerated very quickly. And you see that the peak deceleration is around here, which is just under 70, so maybe negative 68, okay? That is what you'll record in your table for the deceleration of that trial, okay? Now, let's keep that in mind, around negative 68. If I was to remove this. So you are looking for the peak deceleration, and the direction of your phone's orientation is very important because it's not going to be a deceleration if you had it the wrong way around, okay? So now, I'm going to make it different so you see that it works. I'm going to put something soft here. This should increase the impact time, so it should reduce the acceleration. Let's see if that happens. Start the trial, run it. So remembering negative 68 deceleration. Now if we look, you have a similar thing. You started accelerating towards the top of the phone, a little bit of vibration there because the wheels aren't smooth. But then here you have the start of the deceleration. You can already see that it's a more gradual slope anyway. But what are we interested in? We're interested in the peak deceleration. So how tall or how deep is this peak here? Well, you can see here, negative 20, negative 30, so that's about negative 23. So you can see with this set of cotton buds here, obviously that's not a car safety feature, but it works the same way. If we made the impact take longer, then it's going to reduce the acceleration. Why we're looking at the y-axis? Because the phone is facing standing up, and the direction of the impact is towards the top of the phone. Okay, that would be slightly different based on you're probably going to use the x-axis, honestly, if you're using seat belts in a chair. So your phone would be sitting like this, and so the direction of impact would be towards the positive side of the z-axis. All right, so that is a video showing you how to read off the data from PhyPhox. Hopefully that clears things up and makes it more physics correct. I'll see you in the next video.